Hello, everyone, and welcome back. My name is Mr. Cobalt, and in this video, I'm going to be going over again a few examples of writing nuclear equations based on the information that they're giving you. And so the key here is to identify what kind of particle is being emitted or gained, right? And you should be able to identify the particle as well as be able to write its symbol. And then from there, you want to be able to balance the equation where the top numbers, the mass numbers on top, on both sides, the total is equal. And on both sides of the arrow, the bottom numbers, the total is equal. And so that's really all there's to it. So let's get into these examples. So the first example here is alpha emission by plutonium 239. So the 239 is the mass number. So we can start off by noting that this is undergoing the decay. So it's the parent isotope, it's the reactant. And so we're going to undergo alpha emission. Emission means that you are emitting or giving off the particle. So that means it's going to be a product. So the alpha particle is a product. So you need to know what the alpha particle is, and you need to know and recognize that in this case, it's a product. So here the plutonium is our reactant. So we're going to write P, the symbol for plutonium. Let me double check that really quick. That's going to be, where is it? Yes, Pu. So Pu is plutonium. And so the 239 is the mass number that's going to go on top, 239. And if you look up plutonium, get the atomic number from plutonium, that is 94. So 94 is the bottom number. And so that is our only reactant. So that's going to emit an alpha particle. So you need to know what an alpha particle is and what the symbol is. The alpha particle is a helium nucleus. So it's going to have 4 for the mass number and 2 for the atomic number because helium is number 2 on the periodic table. So you can write He, or you could do the alpha symbol, the Greek symbol alpha. Either one is fine. So He, you have 4 and then 2. Your mass number on the bottom, 2 atomic number on top. And then you've got another isotope or daughter isotope that's formed. We need to figure out what that is. And so this is where you need to make sure that both sides are equal for the numbers top and bottom. So the total on the top here is 239. So the total on this side for the top numbers should be 239. So we have 4 here. 4 plus what gives us 239? And if you said 235, you would be right. So you can also figure this out by subtracting the 4 on this side from the total on this side. So whatever you have on this side, except for the missing part, the total, you subtract the total numbers on this side. In this case, it's only 4. And you subtract that from the total on this side, and you'll get the missing number. So 239 minus 4 gives us 235. 235. And you can double check. 235 plus 4 gives us 239. That is correct. So here we have 94 is the total for the bottom number. We have a 2 here. So we need to figure out what the bottom number here is. So 2 plus what gives us 94? 92. So we're going to have a 92 down here. And so since we have the bottom number, that is the atomic number. So we look up 92 on our periodic table, and that is going to be uranium. So here, from plutonium 239, we get uranium 235. Okay, so next one. Here we have sodium 24. It's going to undergo beta emission. So it's going to emit a beta particle. So you need to know that what the beta particle is and what the symbol is, and you have to recognize that it is a product in this case. So the sodium 24 is our reactant. So 24 is the mass number. So sodium Na, the mass number is 24. And then the atomic number is 11 on the periodic table. So this is going to undergo decay. So that means it's going to emit a beta particle. Beta emission means it emits a beta particle. And so the beta particle is an electron. So it's going to be E, 0 for the mass number, and -1 for the bottom number, the atomic number. Okay, so here we have our symbol. And now we need to figure out what the missing isotope is. What is our daughter isotope here? Well, we need to make sure that both sides are equal. So here the top number, the total is 24. So the total here should be 24. 0 plus what gives us 24? 24. So we're going to write 24. And then the bottom number must be the same on both sides. So the total on this side is 11. The total on this side should be 11 too. So -1 plus what gives me 11? Did I say negative? -1 plus what gives me 11? So another way to ask this question is, what minus 1 gives me 11? 12. So 12 minus 1 gives me 11. So the total on this side is 11. And so now we have our atomic number. We looked that up. Atomic number is, I believe, magnesium. Yes, indeed, it is magnesium. So it's Mg for magnesium. And so there's the nuclear equation for this process, this decay. Okay, now we have positron emission. So the oxygen 15 is going to undergo positron emission. So again, the word emission tells us that the positron is going to be a product. It's emitted, it's produced. So oxygen 15 is our reactant here. So we're going to have O, and then the top number is 15 because that's our mass number. Oxygen, I believe, number 8 on the periodic table. Yes, it is. So the atomic number on the bottom, number 8. And then so this is going to undergo a decay. It's going to produce a positron. We need to know what a positron is. A positron is simply a positive electron. So it's going to have this symbol, but instead of a -1, it's a positive one. So it's E, 0 for the mass number, +1 for the bottom number. And now we can figure out what our missing daughter isotope is. So again, the top numbers on both sides should total the same number. So here we have total 15. So the total on this side would be 15. So 0 plus what gives me 15? 15. Very good. You guys are getting it. Okay, on this side, we have 8. And then we have 8, and we have on this side +1 and something. So what plus 1 gives me 8? 7. Very good. So 7 is the bottom number. So 7 is the atomic number. We look up number 7. That is nitrogen, I believe. Yes, it is nitrogen. So that is going to be nitrogen 15. So that is the nuclear equation for the positron emission by oxygen 15. Last but not least, we have electron capture. So the word capture here is the opposite of emitting, right? So instead of emitting and producing the electron, you're going to capture it, you're going to absorb it, you're going to react with it. So the electron here is part of the reactants. So we're going to take our copper 64. So here we have Cu. 64 is the mass number, so 64 goes on top. And then the copper, the atomic number for copper is 29. So we're going to put 29 on the bottom plus the electron. So it's going to capture the electron. It's going to react with the electron. So it's going to absorb the electron. So we're going to write the symbol for electron. It's going to be 0 on the top for the mass number and -1 on the bottom. And so we want to know, well, what is the daughter isotope formed? Again, the top numbers on the top should equal the top numbers on the top, so on both sides. So 64 plus 0 gives us 64. So the top number of our daughter isotope is 64. And the bottom number should be the same. So 29 minus 1 is 28. So that means on this side it should be 28. So now that we have our atomic number, we can look that up. So what is number 28 on the periodic table? That is nickel. So nickel 64 is our resulting daughter isotope. So nickel. And so that, ladies and gentlemen, is how you write the nuclear equations given the information of what kind of decay is happening. I hope this is helpful. If you enjoyed this video, if this helped you in any way, then please by all means like the video, share the video with your friends, hit that notification bell. But before you do, make sure you subscribe to my channel. When you click on the notification bell, make sure that you click all so that way you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you want me to go over, let me know what it is. If you have a topic you want me to cover, let me know what it is down below. I would love to do that for you. Thanks for joining me and have a great day.